Okay, let's see. The website, I guess, is a good place to start. Now, clearly, I am Dermot O'Connor, and I will be presenting this module. And I did mention to you in the first email that I sent out to you that there is a change in the module name, but really, there's no material difference as such in terms of the contents vis-a-vis last year, just in case there are some people that you would have known in last year's fourth year. It's essentially the same material. I'm bringing one new, uh, let's call it a platform, really, which I could easily have brought in last year, but it just wasn't available to me. And we can talk about that when the time arises. But essentially, it's the same kind of thrust in terms of the content that I want to cover. And I have given you the link to this website, which is where I publish all the material. This kind of layout might be familiar to you from, well, in fact, as I think about it now, the web app dev 2 module that you're studying this semester as well. Um, I think it's probably Roseanne is still doing that module. She uses this website structure as well for presenting her material. I don't, and I don't think she does, use Moodle at all, except for assignment submissions. I think I might have mentioned all of that in the email, so there's nothing new there. Uh, so, unless there are any kind of initial startup teething problems that you want to bring to my attention, I can get started with the module itself. I'll just open the floor to you for a minute in case there are any things you want to ask me, even though we haven't looked at anything yet, but there might be some initial issues that I am not aware of. No. Okay. So just to explain the layout here now. So as we cover new topics, there'll be a new card. We call these things cards. And each card behind it will have either one or more sets of slides, and there will also be lab work. I was looking for an image that had lab work rather than homework on it, but homework is very kind of primary schoolish, but apologies about that. So wherever you see a card with homework, that's essentially a lab, but the stuff will become fairly obvious as we work our way through it. And behind this card here is where I will put links for the lectures. I record the lectures. Now, there's been such confusion this morning. I'm hoping this one is being recorded, but this is where all the lecture recordings will ultimately appear. Obviously, there's nothing there right now because we haven't had any lectures. So before I launch into the first topic, and really we will spend quite a while on this topic, like maybe 3 weeks. Uh, but before I do that anyway, let's maybe just try and give a quick overview, and it will be fairly quick, of what I'd like to cover on this module. So if we go into this one here, there's a set of slides, and I'll bring them up on my PowerPoint. There's no real need for you to uh, bring them up on your machines. Right. So, yeah, I've mentioned that. I've mentioned that. Uh, as you know now, I use Slack for pretty much all my communications. So up to now, I've been using Slack and I've been sending emails, but I'll back off on sending the emails really. So it's important that everybody uh, joins the Slack workspace. And the contact hours. So, okay, there's one lecture per week and 3 labs, but sometimes the labs will be more like a lecture than a lab as such. And that's really because of the high practical content that I like to cover in this module and indeed lots of my other modules as well. Now, coincidentally or ironically, there'll probably be no practical content today because we just won't get to it. But just on that point, actually, tomorrow uh, there are 3 hours back to back, which are penciled in as practical hours. Now, certainly for tomorrow, I'm going to use at least 2 of those hours as a lecture. So again, I will publish a link to Zoom that you can use to join that lecture, because clearly we have to cover some theory before we can do anything substantial in the labs. So a good portion of tomorrow morning will be lecture as well. And then other weeks, I'll let you know as we work our way through this as to whether I'll be using some of the Tuesday morning as a lecture and some of it as practical or entirely practical. I'll let you know on the Monday. So this is really what I want to cover in terms of an overview of this module. We'll just start with, well, what software do you need to have installed and or what services do you need to register for this module. Then we'll talk a little bit about the software development lifecycle, which is kind of the framework around which this module is built. Uh, and okay, it's day one, but I'll give you a small kind of peek into the assessment structure. I'm not too sure what that image is doing there on the right. That image shouldn't be there at all. That's coming from another set of slides. So sorry about that. I didn't seem to spot that. Okay, in terms of software requirements, a lot of them overlap with the web app dev 2, as it turns out. So you need to have, but just as a matter of interest, have you had any lectures so far on the web app dev 2 module? Anybody brave enough?
Yeah, we had one lecture.
Okay, that's good. I should say as well, like that. Okay, these lectures are online, but at any stage, feel free to just interrupt and ask me questions. Uh, don't, as I said it there at the outset, I don't tend to keep an eye on the chat um, chat box that comes with Zoom. So, feel free at any stage just to essentially interrupt me. I won't take offense, and if you do have questions. So, no, yeah, you need to have Node installed as you do for web app dev. There is this tool called Docker Desktop, which you may actually start using tomorrow. So you need to install that straight away. It's a pretty foolproof installation. So I'm giving you the URL there that you go to. You pick the Docker Desktop uh, installation that suits your particular operating system, whether it be Mac or Windows or Linux. And it's pretty much just a download and click and install. There's hardly anything in the installation procedure. So try and get that done before tomorrow morning. Uh, I use Git a lot, mainly in terms of evaluating assignments and assessments. So check to see if Git is installed on your computer. I wonder, is that what I meant by the previous one? No, sorry, no. So just type git space minus minus version on your command line of your terminal command line to see if you have it already installed. You may well have used Git in other modules. In fact, you would have used it in the software tools, I'm sure. That would have been in third year, I think. So you need to have it installed locally if it's not already there. The editor that I use, and I know that it's used in VS Code, in Web App Dev is VS Code. So if you don't have that already installed, you need to install it. So that's all on your own machine. Then in terms of kind of cloud services that you need, everybody at this stage, I guess, will have a GitHub account. So it's assumed that you have that. You will need an account on a service called GitLab as well, although we won't need that until well into the back end of this module. So that's not an immediate requirement. You will need your own personal account on AWS. Now, I know ye studied a module in third year that used AWS, but you were provided with, as far as I'm aware, you were provided with AWS accounts that were kind of created especially for you. Those accounts won't work for this module. So you need to actually create your own personal account. Now, that will mean providing a credit card as part of the registration process, but you can be assured there'll be little or no cost associated with um, our use of AWS. And we won't really be using AWS again uh, until the back end of this module. But just bear in mind, uh, you do need to create your own personal account rather than using the account that you may have used up to now in third year in another module. Can't remember the name of the module, but something like automated cloud services or something like that. And there's also a a service that we're going to be using called Kubernetes. I'd say many of you may have heard of Kubernetes. So there's fortunately there's a Kubernetes cluster installation that's available to us this year, which wasn't available in previous years. So it's going to be great now that you'll get some experience of that. Uh, the accounts on this Kubernetes cluster will actually, I'll probably provide them to you. They're going to be created by the administrator for this Kubernetes cluster. Um, so again, that's a little bit down the line, although not too far, maybe about week 3 or 4, we'll be using the Kubernetes cluster. Any questions on that? No. Okay. The software development lifecycle. And okay, once upon a time, there was a software development lifecycle model called the waterfall model. I'm not going to insult you by talking about that now because that is so outdated that it would just be embarrassing if I started talking about the waterfall model. Although you might have covered this in maybe first year or second year, it might have been mentioned and described to you, and that's fine. That's as an introduction to this whole notion of the software development lifecycle. It would have been probably appropriate to cover the waterfall model. But really, in the industry, in the software industry today, very, very few software houses would follow this model. Um, the model that a lot would follow would kind of generically be referred to as the agile model. And that's really where the name of this module came from when it was called Agile Software Practice. It was to kind of reflect the dominant software development life cycle uh, of of the um, uh, of the period, let's say. Now, the agile software development lifecycle, agile is really kind of an umbrella name, as I'm saying here. There are a number of instantiations of this model. One that you probably would have heard of or may have heard of is something called Scrum. So I would say Scrum is a particular implementation, if you like, of the agile software development lifecycle model. Now, more recently, uh, there is this development lifecycle called the DevOps lifecycle or the DevOps model. And it's really an evolution of the agile model. And as you know now, I have renamed this module to be called DevOps practice. And that's really a reflection on the fact that this DevOps approach towards software development lifecycle uh, is it's more than it's gaining popularity. It's probably nearly the dominant one at this stage. Scrum, there's still a lot of Scrum being used, and many software houses would use Scrum and DevOps, the DevOps approach. So for the purpose of this discussion, the DevOps module is just an evolution of the agile model for software development lifecycle. That's how we will view it. Now, this is an image kind of that I put together myself, and it's meant to describe this whole agile approach towards software development. And again, you're probably familiar with a lot of the theory behind this, but I'm just including this for kind of for completeness. Um, and just to kind of quickly explain what this is saying, which you probably hopefully already know, that so we're going to embark on the development of a software application. And so we've done our user requirements analysis, and so we have a list of user requirements and we've prioritized them. Okay, and we've prioritized them in terms of the most important to the least important. Okay, and this agile approach, there are kind of two characteristics to it. It's an iterative approach, so we go through this kind of sequence iteratively, okay, many times. Let me just erase that. How do I erase? I've forgotten how to erase. Yeah. So it's an iterative process, and the second characteristic is there's feedback loops built into the process. And feedback is extremely important. Feedback in the sense that you're getting some feedback from your customer or client or whoever you're developing the software for. You're getting feedback from them, and that feedback kind of informs your user requirements. Because as we know, it's not until the client or customer gets to actually see and play with the software application that you're developing for them. It's not until then that they can give you a better understanding of what they're actually looking for. So this iterative nature and this the importance of feedback in the whole software development lifecycle is what characterizes the agile approach. And just to dig into a little bit more detail then, so for each iteration, kind of what happens is you take whatever is currently at the top of your list of requirements or remaining requirements that need to be implemented. So you take a subset of the user requirements and you essentially design, implement, test those. So that's what's kind of going on inside here. Okay. So you assign tasks to the various team members. So somebody might be responsible for writing up automated tests. Another person might be responsible for designing and implementing a particular part of the subset of user requirements that you've picked off this stack here to design and implement. You're constantly checking to see how things are going on. And at the end of the iteration, you then kind of deploy it. Let's see, where is that being said here? You either demonstrate the current state of the application to the customer, or if the application is actually being used in production, you deploy the new features that you've developed over here. You deploy them into the production version of the software application. And whether you're just demonstrating it to the customer and you haven't really deployed it into production yet, or whether you've deployed them into your production environment, you're getting feedback from your customer as to whether they like the new features, they want them slightly redesigned, um, or changed or whatever, or added to. And that feedback is brought back into your user requirements stack And it may result in this stack being changed in terms of new requirements that were low down the stack are now brought up higher, or vice versa. And so after each iteration, we go back all over again. We now have we still have some more user requirements. Take the top ones, one or a number of user requirements off that stack, put that through this process of designing, implementing, and testing, demonstrate, add the new features to the current state of the application, demonstrate it to the customer, get some feedback. If they're happy with it, deploy it straight into production, monitor what's happening in production, get some feedback from that. So that's the idea behind the agile approach. And I am kind of assuming that people are kind of vaguely or maybe in detail, they're familiar with this approach. Now, where does DevOps come in? DevOps is essentially the same idea. And if you read anything about DevOps, you would have seen this kind of letter or number 8 sideways illustration of the DevOps process. Forget about all of this stuff up here now and down here. Okay, this is the DevOps software development lifecycle. And we kind of start around here, the planning stage. The planning stage, if I go back, is kind of equivalent to, prioritizing your user requirements and deciding what requirements will I develop next in this whole stack of requirements. That's what we mean by planning. Then we implement the requirements that we've decided to go ahead with. We go through a build process, which we'll talk about later on. We do some testing, automated testing, and then we release it and deploy it. So here's where you're kind of either adding the new features and showing it to the customer before you actually deploy it into their production environment. And when we get to around here, we're deploying the new features into a production environment. We're monitoring how it's performing and getting feedback from that. We're also getting feedback up here from the customer. And based on that, then we're back at the planning stage again, and on this kind of iterative process goes. This part of the process is dominated by development. This part over here is dominated by operations. Operations really is where you've deployed new features into production and you're monitoring how it's performing and getting feedback from that monitoring. Now, where does this module come in? We will be dealing with the whole build process, whatever that means, and we're going to spend a lot of time sort of in this area here. So a lot of time in deployment, and this kind of subset that I'm highlighting here, this subset of the DevOps process is often referred to as CI/CD, which stands for continuous integration stroke continuous deployment. And we look at that whole area again at the kind of latter half of this module. So we're not going to be implementing applications or features. You've done that kind of stuff in other modules. We are interested in this notion of building your application, which is where containerization, which is the first topic we'll talk about, comes in. We're interested in this whole CI/CD. We want to automate this part of the life cycle here, and we spend a lot of time looking at deployment. Now, all of these things up here and around the edges, you see, the point is that this whole DevOps lifecycle is highly automated. And that's reflected by all of these various tools and services and cloud services that are available to us today that support the software development process which we will now refer to as kind of the DevOps process. And this module will try and look at a, a subset of these tools. And that's why practice is part of this module's name, DevOps practice. We actually want to get our hands dirty looking at and using a small subset of the tools that are shown here. So that's kind of the idea. Okay, so I've just made that point really, right? That our focus is on looking at tools and services, tools, platforms and services that support software development in this kind of dynamic environment. Uh, okay, and we'll spend a lot of time at the whole kind of deployment part of the process. I'm listing here then the tools that I'd like to cover. So we'll spend quite a lot of time, or initially anyway, on the Docker tool, and that's focused on the whole area of building an application and packaging it. Then we move on to Kubernetes, which is all about deployment. So Kubernetes is a deployment platform. Towards the latter end, then we'll talk about GitLab, which is a platform that we'll use to achieve this CI/CD idea that I was talking about. And if we've time at the very end, we also look at AWS as an alternative deployment platform to Kubernetes, I guess. I'll pause again just in case there are any questions that come to mind for you. No, it's hard to come up with questions really at this early stage because, it's not until we get into some detail, I guess. Assessment, I hate talking about assessment on day one, but people are always interested, so that's why I've included it. So this is the breakdown, 10% on lab work. So there'll be maybe 2 or at most 3 labs that I will ask you to submit to me. Now, I haven't decided yet what the first lab is going to be. So anyway, it won't be the first lab that you'll be doing on the module, but there'll be about 2 or maybe 3 labs that you will submit. And as you'll see, the labs are very prescriptive. So it's merely a case of working your way through them. Some labs will have exercises at the end, but that will only be a small portion of the actual effort that goes into the lab. So in a way, it's quite easy to get the 10%, provided you put the time into the actual lab itself. Then there will be what I'm calling a take-home assignment, your kind of classic assignment, worth 45%. It'll be about week 7, I'd say, before, or 8, before you'll be handing that up. We've got quite a lot of material to cover before we'll be able to give you any kind of worthwhile assignment to work on. And then there will also be what I call a lab-based exam, either on week 12 or 13, depending on how things work out generally for you across the entire semester. And that lab-based exam, it'll be maybe about a 90-minute exam. But it will be in the labs where, you will actually be working on your computers. It's not a pen and paper exam as such. And that's also worth 45%. So that's the breakdown. Any questions on that? No? Okay. So let's go to the first topic, if you like, which is containerization. And easily half of this module is on containerization. So it's a very significant portion. Now there's a set of slides, but as we go through from week to week, I will add more slides set to this section. But for today, anyway, I'm going to start on these slides here, and I will continue. I really need to finish this set of slides before you can actually work on the lab. So that's why the the classes tomorrow morning will be uh, will be lectures as well, just depending on how much progress I make. So I'm going to bring up these slides next. Does anybody know what a container is in the world of software development? Hmm. No? Okay. I don't think you've covered it anywhere, but people might have come across it reading articles or whatever. So our first topic is containerization. And containerization is all about making the whole idea, the area of deployment uh, easier. Deployment is where we kind of if you like, we upload our code to a remote server, I guess. Let's put it as generic as that, where we upload our install our application on a remote server so that our clients and customers can actually use it. Okay, that's a kind of a made up definition of what I mean by deployment. Um, and this is where containerization is uh, useful. It makes the whole area of software application deployment simpler and easier for your software development team. But before I talk about containerization, I like to, whether it's worthwhile to you or not, sort of build up the background as to how we got to a particular to using a particular technology. So the background to containerization is to first of all talk about virtualization. And I'm hoping you've heard virtualization before. You've got some sort of idea of it. You've actually you have availed of this technique or technology, let's call it. You've availed of this technology already. If you think back to I should have really checked the name of the module that you did in third year, the AWS. I'm just going to call it the AWS module. It's something like automated cloud services. Can somebody remind me what the name of that module is in third year that you've covered? We did a lot of AWS
I
stuff.
think you got it right there.
Okay, automated cloud services. Okay, uh, and you were using the EC2 service a lot. Okay, so EC2 is an example of virtualization. And so what virtualization is, and it's kind of represented on this image here on the right, the idea of virtualization is that it allows you to have multiple operating systems installed on one physical hardware. Prior to virtualization, you would just install an operating system and then you ran applications on top of that operating system, which we refer to as the host operating system. But virtualization allows you to install multiple operating systems on top of the host operating system. So, for example, the green stuff here might be our Mac stuff. The orange might be Windows. The red might be Ubuntu or some other Linux variation. And the host operating system, we don't really care. It could be any one of those or some other one. Now, in order to uh, and this is what virtualization is all about. Okay, but in order to be able to install these multiple virtual machines, as they're referred to, we need to install a piece of software called a hypervisor. Okay, so that's just a a tool that you need to, utility maybe, that you need to install on top of the host operating system. And then once you've got that, you can then install multiple virtual machines, as these are referred to. And there's obviously benefits to virtualization. It now means if we want to run an application that's only available on a particular operating system, then we can now achieve that. More generally, if your base hardware is actually a data center or a cloud provider, then, and that's where, in the case of cloud provider, that's where EC2 comes in. But if your base hardware is a data center or a cloud provider, they kind of overlap really, those two, then typically in that scenario, there wouldn't be a host operating system. There would just be the hypervisor. You can install the hypervisor directly on top of your hardware. And then once the hypervisor is installed, you can have VMs or virtual machines running on top of that. And that's really the way AWS, for example, works. So these could be EC2 instances uh, in the case of AWS. And I, I guess the question is, why? Why would you want this? Well, at a personal level, it's running on top of your own PC. It just means you get experience with multiple operating systems rather than just a host operating system. But in a cloud stroke data center environment, the benefit of VMs is that this application here may be uh, owned by one customer of AWS, and this application is owned by another customer, and all of the applications are owned by different users or customers of, let's stick with AWS. And maybe those customers are very particular in terms of their security. They want to make sure that their application is completely isolated from any other application that might be running on the same hardware for security reasons. And that's a reasonable requirement that they may have. Now, virtualization allows you to achieve that because each of these VMs is completely isolated from one another. You cannot, on this VM, somehow try and get access to another VM. The hypervisor will prevent that. So there are very worthwhile security benefits from this whole virtualization. And virtualization has been around for decades, okay? But it's probably only within the last 20, 25 years that it became popular. The advantages then, I don't want to spend too much time on this now, but clearly we no longer uh, need to have different uh, physical hardware for multiple operating systems. We can now run multiple operating systems on one physical piece of hardware. So there's reducing cost from a hardware point of view. Um, the idea was that, if you take a global view and you've got a particular, let's stick with AWS because that's the one we're familiar with. AWS would have data centers um, distributed globally. Okay. And what virtualization would allow you to do is you could run an application on a VM uh, on at a particular data center and maybe move that VM to another data center in a different part of the globe or have duplicate copies of it. And the benefit of that would be there are a couple of benefits. Your user base for the application, the actual end users, you know, if it's daylight time in the US, it's probably nighttime at the other end of the globe. So you don't actually need to have a VM running the application. Uh, it only needs to be running wherever daylight is current. So you could physically either, well, it's not physically, but logically kind of move the VM to a different data center. Or more likely, what you would have is have multiple copies of it but have it shut down on the data centers that are in nighttime period and have it running on the data centers that are currently daytime. So there's this kind of follow the sun, follow the moon idea. The follow the moon would be if the nature of the application is such that it does a lot of batch processing, then the batch processing could be carried out in a data center that is currently nighttime. So that's kind of the idea. So there's a lot of kind of flexibility and mobility, if you like, in your applications. This is what virtualization makes easier. You could argue you could do that when your application is running on the host operating system as well, but it's much trickier, I guess. Also, improve scalability. Scalability is always the very important thing when you're talking about applications that is available to a global user base. And so typically with scalability, if I go back to this image that I have, with scalability, what you might have is uh, you would have multiple VMs running the same applications scattered across the globe. So if we just take Europe and America, for example, which would roughly be, there might be users in both continents using your application at the same time. So you would have one data center in the US serving the user base, the US customer base. You'd have another data center with your VM serving your European user base. So you'd have duplicate copies, and that's enhances scalability. Once the US goes into nighttime mode, you could either scale down or shut down that VM, and now maybe boot up a VM in the Asian region or that kind of idea. So that's kind of the general idea of scalability, greater hardware utilization for sure, more flexibility, which is kind of along the lines of what I was talking about. The downside of virtualization, though, is it's what we say is it's heavyweight. So each virtual machine, if I go back to this image here, it means that each application needs an entire operating system uh, available to it, plus whatever, you know, binaries and libraries that the application needs. But in particular, it needs a complete installation of the particular operating system that it depends on. Uh, and when you've got obviously when you've got each of these VMs, virtual machines, they're all consuming hardware resources, CPU, RAM, memory. So each of them is quite hungry in terms of hardware uh, resource needs. Okay. So that obviously reduces the number of VMs that you could have running on a single physical hardware platform. So there we say that they are quite heavyweight from that perspective. And really that's the primary disadvantage with them. Um, Also, if the operating system is a license, then you need a license for each VM, essentially, if that's an issue. I've already mentioned this point. Uh, Operating systems are constantly being uh, updated, mainly for security reasons. So there's a lot of maintenance overhead associated with each virtual machine that needs to be managed by somebody. And it's really for those reasons, the heavyweightness, that an alternative solution emerged, and the alternative solution is containerization. It's the same idea that we want in the sense that we have lots of different applications that need to be isolated from one another in the context of a data center or cloud provider. So that isolation is an underpinning or base requirement, whether we use the virtualization approach or containerization approach. But with containerization, uh, you're guaranteed this isolation objective as well. We don't need to look into the detail as to how that's managed down at the kind of OS level, but suffice it to say that it is a guarantee that's part of this whole containerization kind of solution. So you've got isolated environments running apps and services. The isolation is at the operating system level, which is, down at the fundamental level. So, okay, we had isolation with virtualization as well, but we still have it with containerization. Just from maybe if we look at the image and contrast that with the earlier image, it now means that, each application now, it still needs the binaries and libraries uh, as part of its installation, if you like. But we no longer have the need for an accompanying operating system. There can be a host operating system, and in the case of a data center, there may not be. But the equivalent of the hypervisor is what we call a container engine. So that does need to be installed on whatever hardware you want to avail of containerization. And then once you have this container engine software installed on the hardware, then you can run multiple containers, as these are now referred to, as opposed to virtual machines. But as I've already said, each container is physically much smaller than its virtual machine equivalent. The portability, because it is smaller, it's actually much quicker to create them. And also it's actually easier to move them from one physical hardware platform to another one, if that was a requirement. It's also much easier and quicker. Quicker is probably the key word, to replicate them on multiple hardware platforms. So we're going to be looking at, how do we create these containers? That'll be part of what we want to look at. But just to get the high level perspective is really all I want to do today. And I'm not doing it quick enough, really. So I'm probably better off stopping here now. So I need to finish off this set of slides, as I've already said, tomorrow morning. I will put a Zoom link, which hopefully will work this time, up on Slack this afternoon. And I will talk to you then, maybe. That's about it, really. So before we close off, are there any questions that have come to mind to you since I last asked you?
Dermot, I needed to add it to the Slack.
Did you not get the invitation link? No?
No, I didn't get an email.
Can you send me an email and I will reply back with the invitation link. So my email address, do I mention it at the top there? Did I mention it? Just give me 1 second. Okay, that's my email address there. Just to your Connor.
Yeah, great. Thanks.
So if you just send an email, just a one-liner is all I need, and I will return with the link to you. Anything else from anybody else? No. Okay, I'll talk to you tomorrow morning. Bye-bye.